So I'm Jared from AskEdith, and today I'd like to share 5 reasons why AI is the future of SQL accessibility. So first of all, there's a lot to love about SQL. It's very easy to read and to write for those of us who work a lot with it. It's English-like, it's declarative, it's common across many different data systems, aside from maybe some small quirks with dialects, but someone who works with Postgres can comfortably work with MySQL and so on, and it's highly optimized. But even so, there's some problems with SQL that AI can solve. So to kind of illustrate this, I want to go through a quick example. So consider Jason, who is a product manager at a toy company on the e-commerce team. It's a week before Christmas Eve, and he notices a drop in purchase volume. And he thinks, okay, maybe this is just that people are busy, or it could be a search feature that his team just recently shipped. So first, he'd like to ask some questions. Okay, what were the numbers from the same period last year? And also, what percentage of the search results are being added to cart compared to last year and last month? And so Jason's going to have to get in contact with the data team to answer these questions. And of course, the data team is busy. Maybe holiday seasons, there's a general uptick in data tickets. And also, the data team doesn't magically get more analysts when it's busy. But say Jason kind of explains the nature of the problem, and everyone agrees, okay, this is an important thing to get answered. And so Jason gets a hold of someone, and now he needs to re-explain the problem. So he'll have to give context to another person, and Jason maybe has some ideas of where to look. And the analyst maybe goes and digs down in that direction. They come back with some answers, and together they figure out maybe where next to go. Of course, this process takes a long time. It can be hours or days of this back and forth between Jason and the data team. It's a very typical interaction between a stakeholder and the data analysts. And because of that, is very kind of frustrating. It teaches Jason not to go to the data team unless absolutely necessary. There's some questions that maybe are not the most critical, but if we can get them answered, really can benefit the rest of the company. And of course, all of this is costing a lot of money. The unit cost of an analyst's time is quite high, and ad hoc questions also tend to be some of the most resource draining for the data teams. So to kind of summarize, today ad hoc analysis is like going all the way to the grocery store every time we need an ingredient while we're cooking. So the question is, can we bring the analytics closer to the stakeholders? What if we could directly translate the stakeholder questions into data queries using AI, so that we can ask a question like, what percentage of search results are added to cart per day for the last 3 months? And we can instantly generate the SQL query, and we can return the results. So with a system like this, it'd always be ready to answer the questions, never too busy. It's always working. It scales up and down during holiday season or whenever. We're able to consolidate the stakeholder and the analyst, so we'll have much faster iteration cycles. And the stakeholder can quickly use the results from one question to inform the next. We'll have much faster turnaround time so that project success is no longer dependent on someone outside of Jason's team. And we minimize frustration, so it teaches Jason that he can kind of solve these questions on his own. And of course, it's cost effective. So the unit cost of the question is much lower, and now we can use analytics to effectively solve some maybe lower value questions. So if going to the data team is like going to the grocery store every time we need an ingredient while we're cooking, having AI translated SQL is like installing a data fridge for the stakeholders. Okay, so how does this work? Well, we start by training a large language model to translate English to SQL. So large language models, which I'm sure many of you have heard a lot about now, ranging from GPT-3 to ChatGPT, these are large language models that are able to translate or are able to take text input and generate natural language outputs. So we're training this on English and SQL pairs, which gives us a fairly strong starting point. So we ask, what are the best-selling products in the US in 2022? This is a real generated SQL, by the way. We're able to pull from the invoices table, do the correct filters. We're able to group by the item, and then calculate the sum of the amount and order by that, that sales number. So this is already pretty good if we can do this in 15 seconds. Now, if we ask, what's the total sales in California, but our data has where the state column is the two-letter code for the state, so we have state equals CA, well, we can't expect the user to be aware of the data format. We want them to ask the question exactly as they would to the data team, and then for the AI, well, in this case, the AI to be able to translate that to state equals CA. So we take a little inspiration from human analysts here. When writing a query, a human would kind of search and sanity check by looking into the contents. That's the typical select star limit. We want to enable the AI to do the same so that they're able to search into the data and kind of adjust as they're writing the SQL query. So now when we ask, what's the total sales in California? Now we're able to correctly match where state equals CA. OK, so this is pretty good now. But there is a small problem. So writing correct SQL is not just as simple as translating and searching. The same SQL query can be considered correct or incorrect in different contexts. So an example here, what's the total revenue for the product ABC123? This SQL query looks to be correct. However, what we're not told is that ABC123 is the base terminology for the product. But when our salespeople are selling ABC123, there's always configurations of it. So ABC123-A-B-C. In this case, the correct SQL query is actually like ABC123, matching all of the configurations. So what we're talking about here is the business context that the question is asked in. If finding the correct SQL query is a search space, it's not just the input question that's asked and the data schema. We also have to take into account the business context, which what we're talking about here is a semantic layer, which is the business representation of the data that enables us to kind of access it in a standard way. So the semantic layer has become a fairly standard component of data infrastructure. It sits on top of the data warehouse, but before an analyst is working with Power BI or they're building their kind of dashboards and reports, are interacting with the semantic layer to understand maybe the products do need to match by the configuration. So similarly, our AI must be trained to understand the semantics of the question in the context of the data set. We want it to be able to interact with the existing transform and metadata layers. So kind of all together here, I know that this is very big picture. It's not going into too much detail. Kind of all together, we take a large language model and we train it to write SQL. We enable the AI to search into the data. And then we enable the AI to interact with the semantic layer. And then on top of that, building in some safety and security checks so we're not dropping any tables or columns. And we're able to write some fairly complex SQL. So we ask, what's the year-over-year growth of ADT 760 in Europe between 2015 and 2022? Here you can see, if you have good eyesight, we've got a join between 3 different tables, the sales invoices, the items, and the customers. We've got matching for ADT 760 and all configurations of it, matching for the correct territory and the correct time period. And then we have the extract year from the date column, grouping by that, ordering by it, and then using the lag function to calculate the year over year, which is a fairly involved SQL query that could take an analyst well longer than 15 seconds to write. So it's our view that SQL adoption is going to dramatically increase, but not all users are going to be writing SQL directly. Our goal is to enable essentially anyone to work with these data systems in a zero training, instant access way. All right, thank you so much, and happy to answer any questions. Yes. Sure. So in addition to the generation of the SQL query, we actually have a semantic search layer. It's a lot like Google search. It's just searching into the table schema, so the table names and the column names and the contents of the columns. Yes?
How does it translate? I'm assuming for your training data set, you're getting some form of data dictionary from somewhere. So this requires a fully documented landscape of data input, correct?
That's right.
So you can't just apply this to your average corporate database system where everything is named DB underscore 126 underscore TBL underscore NAW.
That's right. So you can't apply it to something like that off the shelf. That's kind of the purpose of the semantic layer. So if that information exists documented in the transform layer, then that would work. But if we're talking, kind of raw, just mishmash of table names and column names, then you're right.
I was just curious because theoretically, if I was coming into this, I would want to be able to point it in my Salesforce instance and understand that. However, Salesforce, if you're looking for a database, looks exactly what I just described, and no one's going in and documenting it anytime soon. Do you have helper tools to allow for the auto-enrichment of those tables, or some form of way of making all of that documentation that's always on the backlog suddenly exist?
Yeah, so AskEdith integrates natively with dbt. And we're pulling the models from dbt. But it also comes with a kind of a native built-in data transform layer that allows you to kind of do some of this prep work, where you'd essentially be kind of adding like an also known as, this table is also known as this. Does that sort of answer your question?
Not really. That still requires someone to go in and manually document potentially hundreds of thousands of tables and potentially millions of columns manually before this could ever understand anything.
You're right. I think that there are some limitations of what we're able to do automatically today. For the well-documented kind of table schemas, this works out of the box. But unfortunately, if there's no signal in the name of the table or the columns, we're just not able to really kind of pull much from that.
It's just not English.
I'd be happy to talk to you more about this. I've never seen anything like this. I'd be curious to learn more.
Yeah, we can talk afterwards.
Sure. Okay. Yes. Do we depend on any OLAP tools like Tableau? Right, so are you talking about integrations with Power BI or Tableau? No, so we don't have any of these integrations today. Everything that we present to our users from the BI perspective is native to AskEdith. But this is something that we are working on to have a tighter integration with existing BI platforms.